Okay, this is activity 25-4. The answers to check your understanding and practice. So I'm gonna jump over here. And it says, okay, so here's the diagram. Write a clear and convincing argument that the measure of angle A equals 1/2 A minus B, which ends up being 180 minus B. Okay, so again, they want it in terms of B. Okay, so in other words, that means that we want an equation that doesn't have an A in it, because right now, this is what our formula says. Our formula says that the measure of the angle is equal to half the difference of the big arc minus the little arc. So since they don't want A in it, that means we've got to come up with what A is equal to. Okay, so if B is the variable that we want, then we can write A right here in terms of B by saying, well, it's going to be 360 minus whatever B is. So if we rewrite this, the measure of angle A is equal to 1/2. Now take the big arc, which is 360 minus B, and then subtract the little arc, which is B, okay? Then the measure of angle A is 1/2 of 360 minus 2B. Oops. And this is the one time where I actually am going to distribute the 1/2. The measure of angle A, half of 360 is 180. Half of negative 2B is negative 1B. And we have the measure of angle A is 180 minus B. Then for this section right here, they want us to go to graphing software, geometry software. So I went to GeoGebra. I drew circle P with points X and Y on it. I then made a tangent. I used this option right here to make a tangent through X and through Y. I named that point of intersection W, and then I measured this angle down here, YPX, and then I measured angle YWX. All of that was the instructions that they gave me. It says now let's change this angle. So I really don't want this circle to change sizes, and I know that there is a way for me to lock that circle so that it won't change sizes, and I cannot remember how to do it. So I played with it for several minutes, and then I thought I'm wasting time. So I'm just going to move Y closer to X. I'm trying to keep the circle the same size, but it really doesn't matter. What happens as I move Y closer to X? Well, the angle at the center, the central angle, is getting smaller. What's happening to the angle that's at W? It's getting bigger. And not only is it getting bigger, but it's also getting closer and closer and closer to the circle. So the closer to the circle is, the bigger the angle is. Well, what happens when I move Y around here? Okay, so now X and Y are really far apart, so this angle right here is getting bigger. It's 140, and angle W has moved far away from it, and it's getting really smaller. So they wanted to know, describe what happens to this angle as this angle changes. So the two changes that I would say is, as the central angle gets bigger, the angle on the outside gets smaller, and vice versa. As the central angle gets smaller, the angle on the outside gets bigger. Or you could just call it angle W. Okay, so I'm not going to write that down because I'm just that lazy. But that is the answer to that one. You would just say what I just said. Okay, so I'm going to run down here and do number 11. Number 11 was find the measure of angle 2 if the measure of angle 1 is 34. Okay, so I've written down the formula. This is what I know to be true right here. This is the formula that, I'm using the eraser. This is the formula that we have. The angle is equal to, and we're talking about the angle on the outside. The outside angle is equal to half the big arc minus the little arc. So this is an outside angle. So if I'm paying attention to what angle 2 is an inscribed angle. And angle 2, since it's an inscribed angle, I need to know what this arc is right here. This is the arc that I need. I guess I could highlight it. This is the arc that I need, this arc right here. Well, I'm going to have that arc. This arc is used to find the measure of 34. So since that's the one that I want so that I can find angle 2, then I'm going to make this easy and call this measurement X. And the reason that I call that X is because now I can call this one 360 minus X. Now I could have done it the other way around, but then if I called this one X, then this would be the one that I'd be finding and I'd have an extra step to do. It doesn't matter though. You could do it. So 34 is equal to half of the big arc, which is 360 minus X, minus the little arc, and the little arc we're calling X. So this is the big arc minus the little arc. So I'm going to get rid of the 1/2, multiply both sides by 2, and that's going to give me 68 is equal to 360 minus 2X. I'm going to add 2X to both sides, and I'm also going to subtract 68 from both sides. Add 2X, and that's going to give me 2X is equal to 298. Don't trust my arithmetic. 360 minus 68. 292. See, I knew you couldn't trust me. 292. Divide both sides by 2, and you get 146. X is equal to 146. So I now know the measure of this arc, which is 146 degrees. And for inscribed angles, the angle is equal to half the arc. So the measure of angle 2 is equal to half 146, and half of 146 is 73. All right, so the measure of angle 2 is 73. Seemed impossible to find all of those measurements given just that one little piece of information. All right, so we go down here to number 12. They wanted us to find WE. So WE, I'm just going to try to ignore everything else. WE is what I'm looking for. So I'm going to call WEX. That's what I'm going to call it. That's X. If this piece is X, then this piece right here, WIE, that's 360 minus X. So here's the measurement. The angle is equal to 1/2 the big arc minus the little arc, just like I problem I just got through doing. Multiply both sides by 2, and I get 32 is equal to 360 minus 2X. Add 2X to both sides and subtract 32, and I get 360 minus 32 is 328. Divide both sides by 2, and X is 164. So the measure of arc WE is 164. B, find the measure of arc WIE. Okay, well, I already know that this one, right, WIE is 360 minus X, and X is 164. So B is 360 minus 164. So that's equal to 196. The measure of angle OAC, that's this one right here. They want that. Well, in the information up here, they gave me the measure of arc OC. This is what kind of angle? It's an inscribed angle. So this angle right here has this inscribed arc. Okay, because here's the side of the angle. Here's this side of the angle. Here's this side of the angle. And the intercepted arc is in the middle. So the measure of that angle is half the arc. So for part C, we're going to do the angle is equal to half the arc. So the measure of angle OAC is equal to half of 96. And 96, half of 96 is 48. So this measurement right here is 48. All right. Now they want me to find the measure of MOA. MOA. I'm going to change colors just because it's going to get crowded. So they want me to find this angle right here. Okay, well the first thing that I notice that this, let me change highlighters. Okay, I have a triangle right here. And I know this angle right here. I'm looking for this angle, and I know that exterior angle. So that means that for, this is part D, I believe. So for part D, I know that 16 plus the measure of angle MOA is equal to 48. Because the remote interior angles equal the exterior angle. And for this triangle right here, you extend that side on out, and that's an exterior angle. So to find the measure of angle MOA, all I have to do is say 48 minus 16. And if you say 48 minus 16, I believe you get 32. So that is 32. So this angle right here is 32. The measure of arc AM. Okay, well, this is an inscribed angle. Okay. Let me see if I can erase some of this. Okay, there we go. And let's erase this too. Okay, so now let's highlight it in green. So this angle right here has this arc. That arc is intercepted by that angle. So that, and the angle's vertex is on the circle, so that means it's an inscribed angle. So for E, the inscribed angle, let's change colors. Let's do orange. So for E, the inscribed angle, which is 32, is equal to half of the intercepted arc. So half of the measure of arc MA. All right, so I'm looking for MA, so I want the 1/2 to go away. So multiply both sides by 2, and you get 64 is equal to the measure of arc MA. So, or AM, sorry, doesn't matter. 64 is the answer there. Okay, so this right here is 64. And the measure of angle CNO, okay, so this angle right here, this is what we're looking for. Okay, that's an angle on the inside. So the angle on the inside, so for F, we need the angle is equal to half the sum of the arcs. Okay, so half the sum of the arcs. So the angle, that's what we're looking for. The angle is equal to half the sum of the arcs, and the arcs are 96 plus 64. So half of that, 96 plus 64, is 160. So we're going to take half of 160, and that's going to be 80. So the measure of angle CNO is 80. Okay, now last one. It says if AC, this chord right here, so I'm going to mark it, and OM, this chord right here, if the chords are equal, then the arcs are equal. So I'm going to highlight those in pink. The arcs are equal. And I believe that I know these two arcs. So that leaves an equation I can write. Let me change this to, I don't know, let's do green. So for part G, I can find the measure of angle AOC. Okay, so AOC is not even drawn up there, so let me draw it right quick. And can I change? Yeah, I'm going to make it smaller so that it looks, so it matches this. So we're going to draw C in here. AOC. So that's what they want us to find. And let's see if I can highlight it in orange. And they want this angle right here. That's the angle that they want. Oh my goodness, OC, the orange one. So that means that I need this arc right here. Well, I know these two right here. I've got 64. Let me go back now, make that green, and let's make it a little bit bigger. Okay, so I know that 64 is one arc plus 96 is the other arc, and these other two are equal, so I'm going to call them X because they're the same measurement. So if this is X, this is X. Okay, and I know that all of those have to equal 360 because that's how far around the circle is. So 64 plus 96 is equal to 160. So if I simplify this equation, I get 160 plus 2x is equal to 360. Subtract 160 from both sides and I get 2x is equal to 200. So that means x is equal to 100. Now remember, x is the measure of this arc right here. And they want the measure of an inscribed angle. So the inscribed angle is half the measure of the arc. So that's 50 degrees. All of these should have degree marks on them. Don't be like me. Put your units on there. Okay, that ends activity 25. Thank you for watching. Let me know if you have any questions at all. Got to figure out how to stop it now.